Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, Paper 2, Variant 1. And this is the second paper from May-June 2023 exam series. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics, and also you can have better understanding of these questions. And in today's lesson, our main focus will be on mechanics questions, means we will try to discuss first half of the paper. And in the second half of the paper, we will talk about waves, we will talk about electricity, and we will talk about radioactivity. Let's study together, let's improve together. In today's lesson, we are talking about May-June 2023, Paper 2, Variant 1. Total time for this exam is 1 hour and 15 minutes, and you need to answer all questions on this paper. And total mark for this paper is 60. On the second page of exam paper, some important data is given to you, means values of some important constants are given to you, and in the exam if you need value of any constant, you can come to the second page and you can find value of constant. And also on the same page you can see some basic and important formulae. In the exam, if you are in doubt, means you have doubt about any formula, or you have forgotten any formula from AS Physics, you can come to this page and also you can see some important formulae are given to you. But these are not all the formulae you need for your AS Physics. It's very important that you understand how to derive the formula, because when you derive the formula, you understand the physics behind that, and it's very helpful to understand physics. Question 1, part A says define power. Power is rate of doing work. Simply we can say work done per unit time. If same amount of work is done in shorter time, it means power is greater. If same amount of work is done in longer time, it means power is lower. So simply we can say power is work done per unit time. And this question has only 1 mark. If you write down this one, you will get 1 mark. Second part says use the definition of power to show that SI base units of power are kg meter square per cubic second. Very straightforward question. So we have to use definition of power, and power we have already discussed. This is equal to work done per unit time. So simply we can say this is work done over time. Work done over time. And work done is equal to FT divided by time taken. And force we can write down F is equal to MA, and here we have D, and this is divided by time. And for mass we have SI base unit, that is kg, and for acceleration we have SI base units, meter per second square, and for the displacement we have meter, and for the time SI base unit is second. Now we just need to simplify, so we can write down this is kg meter square and s to the power of -3. So this is how we can prove, and this question has only 1 mark. If you have derived this one, you will get 1 mark. Part B says the intensity I of a sound wave moving through a gas is given by this equation, where F is the frequency of the wave, A is the amplitude of the wave, and V is the speed of the wave. K is a constant that depends on the gas. For this question, we need to determine the SI base units of K. As we need to determine SI base units of K, so simply we can make K the subject of this equation. So we can write down K is equal to intensity over frequency square times amplitude square times V. So first of all, we can write down SI base units for each quantity. So this is a proper way of writing. So for frequency we have SI base unit, that is per second, and for amplitude we have SI base unit, that is meter, and for speed we have SI base unit, that is meters per second. And for intensity we need to understand this is equal to power over surface area. And for the power we have already derived SI base units, that is equal to kg meter square per cubic second, and for area is meter square. So from here we can cancel meter square with meter square, so simply we left with kgs per cubic second. So we left with kgs per cubic second. So we can say kg per cubic second. So this is SI base unit for intensity. Now simply we need to plug in these units. For intensity we have kg per cubic second, and for frequency we have per second, but its power is 2, so this is s to the power of minus 2. And for amplitude square we have meter square, and for the speed we have meters per second. Now we can further simplify this. We can write down this is kg per cubic second, and here we have s to the power of minus 3, and we have m to the power of 3 here. Now simply we can cancel s to the power of minus 3 and be left with kgs per cubic meter, or simply we can say this is kg per cubic meter. So this is the SI base unit for K. So we can say this is kgs per cubic meter, SI base unit for K. For second question, part A, we need to show that vertical component of the tension in the string is 2.4 Newton. So here we have the string and we need to show that vertical component is equal to 2.4. So question is simply asking us the vertical component, means this component. This is the vertical component, and vertical component will be equal to 4.8 sine of 30 degrees. So simply we can say T vertical, this is equal to 4.8 sine of 30 degrees, and if we solve this one, this is equal to 2.4 newtons up to 2 SF. And this question has only 1 mark, and this one should be the answer mark. Part 2 says, by taking moments about the hinge, determine the weight W of the beam. So simply we have to take moment about this point. So this is over pivot point. So simply you can imagine this one is the pivot point. This is over pivot point. And in the question it is given to us the force by the spring in upward direction is equal to 8.2 newtons. So the moment due to this force, this will be counterclockwise. So we can say this will be CW, CCW counterclockwise, and moment due to weight, this one will be clockwise, and moment due to this force, this also will be clockwise. And tension has 2 components. One component is acting vertically downwards, and the magnitude of this one is equal to 2.4 newtons, and moment due to this one about this pivot also will be clockwise, but moment due to this component will be equal to 0. So we can say moment is equal to 0 due to horizontal component, because this is passing through the pivot, so moment is equal to 0. Now simply we need to write down counterclockwise moments has to be equal to clockwise moment, and counterclockwise moment we have 8.2 times the distance from the pivot, that is equal to 0.5, and this one has to be equal to the moment due to this weight W times distance we have 0.60 plus moment due to this one, force is 0.30, and the distance is 0.80 plus due to vertical component, that is 2.4, means vertical component is equal to 2.4 newtons, and the distance from the pivot, so here we have 8 plus 0.4 means 1.2, so this is 1.2. Now if we solve this one for W, we will get value of W is equal to 1.6 newtons. So the final value of weight is 1.6 newtons up to 2 SF. So this is how you need to answer this part of the question. For our third part, we need to calculate the horizontal component of the force exerted on the beam by the hinge. Mean horizontal component of the force exerted by the hinge on the beam. So we need to understand, as this beam is in equilibrium, so the resultant force in any direction has to be equal to 0. So if you look at forces acting along horizontal, means sum of the forces along horizontal, it has to be equal to 0. And in this case we have one force that is acting to the right, and this is the tension in the spring, so we have this is TH, and TH in this case will be equal to 4.8 cosine of 30 degrees. As this beam is in equilibrium, so force by the hinge on the beam, it has to be to the left. So it has to be to the left, force by the hinge. And force by the hinge has to be equal to the horizontal component of the tension in the string. So simply we can say force due to hinge, this one has to be equal to horizontal component of the tension, and horizontal component is equal to 4.8 cosine of 30 degrees. And now just we need to solve, and if we solve this one, our final answer will be equal to 4.2 newtons. So this is the horizontal force exerted by the hinge on the beam. So this is just conceptual question. So forces in all directions, sum of the forces has to be equal to 0, otherwise beam will accelerate, beam will not be in equilibrium. So this is how you can calculate, and this question has only 1 mark, and this one should be the answer mark. Part B says the spring obeys Hooke's law and has an elastic tension energy of 0.32 joules. Calculate the compression of the spring. For this question, it is given to us the force applied by the spring on the beam is 8.2 newtons. So the force applied by the beam on the spring also has to be 8.2 newtons, and these two forces have to be in the opposite directions because these are action and reaction forces. And for this question we need to calculate EPE, we need to calculate compression, but EPE is given, and elastic potential energy of the spring in this case will be equal to the work done by the force on the spring, and this one will be equal to 1/2 Fx. So we have value of EPE, in this case value of EPE we have. So simply we can plug in that value, and we have value of force, and we can calculate value of x. EPE is given to us, that is 0.32, and here we have 1/2, and force is given, that is equal to 8.2, and we can calculate value of x. And if we solve this one for x will be equal to 0.078 meters up to 2 SF, because the raw data in this question we have up to 2 SF. So the final answer also should be equal to 2 SF. So this is how we can answer this part of the question. Part C says the string is cut so that the spring extends upwards. This causes the beam to rotate and launch the block into the air. The block reaches its maximum height and then falls back to the ground. Figure 2.2 shows part of the path of the block in the air shortly before it hits the horizontal ground. The block is at a height of 0.090 meter above the ground when it passes through point A. Means when it is passing through point A, its height is given to us. The block has a kinetic energy of 0.044 joules when it hits the ground at point B. Mean at this point the kinetic energy of the block is given to us, that is equal to 0.044 joules. Air resistance is negligible. Calculate the decrease in gravitational potential energy of the block for its movement from A to B. Means when block move from A to B, what is decrease in gravitational potential energy? So this question is pretty straightforward one. So we need to calculate decrease in GPE. So simply we can say delta GPE in this case will be equal to mg delta h. And for this question, weight of the block we have, that is equal to 0.30. So this is the block, weight of the block we have. So simply we can write on this is 0.30, and the decrease in height, that is equal to 0.090. Now if we simply multiply, we will get 0.027 joules. So this is decrease in GPE of the block between A and B. So our final answer is 0.027. And this question has 2 marks. The first mark will be if you have written this formula, you will get 1 C mark, and if you have got the right answer, you will get 2 marks. Part 2 says use your answer in C1 and conservation of energy to determine the speed of the block at point A. It simply means that we need to find the speed of the block at this point. So simply we need to calculate value of V. And for the block the weight of the block is given, so we can calculate mass of the block. So we can say mass of the block will be equal to the weight of the block divided by 9.81. So this is mass of the block. Now for this question, we have already calculated change in GP from A to B. So we can write down here change in GPE. This one will be equal to GPE at point A. If this is our reference line, mean here if we take GPE is equal to 0. If GPE here equal to 0, we can say change in GPE is equal to GPE at point A, and that is equal to 0.027 joules. So this is value of GPE at this point. We also have value of kinetic energy at point B, means when it just gonna hit the ground, at that point we have kinetic energy that is equal to 0.044 joules. So it simply means that this is the total energy of the block, because in this case for this question it is given to us that A resistance is negligible. So simply we can say the total energy at point A, this is equal to the GPE at point A plus kinetic energy at point A. So we need to calculate kinetic energy at point A first of all. So this one will be equal to the total energy at point A, and total energy at point A is equal to 0.44, because in this case mechanical energy is conserved, minus GPE at point A. GP is equal to 0.027. So if we solve this one, we will get 0.017 joules. So this is the kinetic energy. Now we need to calculate speed. So kinetic energy will be equal to 1/2 mv square, and this is equal to 0.017. From here we can write down V will be equal to 2 times 0.017 divided by m and root of this one. Now simply we need to plug in value of m. So we have 2 times 0.017 divided by mass, that is equal to 0.30 divided by 9.81. Now if we solve, we can get value of V, and value of V in this case will be equal to 1.1 meters per second up to 2 SF, because the raw data in this question we have up to 2 SF. So this is the answer for this question, and if you have written these steps you will get 3 marks. Third part says, by reference to the force on the block, explain why the horizontal component of the velocity of the block remains constant as it moves from A to B. So for this purpose we need to understand, if we take the velocity of the block at point A, velocity is pointing in this direction, and this velocity has 2 components. One component is vertically downwards and one component is to the right. And now if you look at the forces acting on this one, there is only one force acting on this block, and that force is force of gravity. So due to force of gravity, the vertical component of the velocity will go on increasing, and as there is no force along horizontal, so the horizontal component of velocity will remain constant. So simply we can say in this case resultant force is vertical, or simply you can say gravity is acting vertically downwards. So we can say resultant force in this case is force of gravity, is vertically downwards. So simply we can say resultant force is vertically downwards. That's the reason horizontal component will remain constant, because there is no force along horizontal. And this question has only 1 mark. If you have written this point, you will get 1 B mark. I mean, this one has to be in your answer. Part 4 says the block passes through point A at time TA and arrives at point B at time TB. On figure 2.3, sketch a graph to show the variation of the magnitude of the vertical component Vy of the velocity of the block with time t from t is equal to TA to t is equal to TB. Numerical values of Vy are not required. So we have already discussed, as the block is moving in this direction, this is the velocity, and the force acting on the block is only in vertical direction. So this is vertical component of velocity, and here we have, this is the horizontal component of velocity, and the force is acting only in vertical direction, and this is the single force acting on the block. So it simply means that Vy will increase with constant acceleration. As the resultant force is constant, so acceleration is also constant. So acceleration is also constant. And here we have V against t graph. So it means the gradient of Vt has to be constant. Gradient of Vt, this is equal to A, and this one has to be constant. So simply we have to draw a line with positive gradient. So if we take downward is positive, if we take down is positive, so it means acceleration is positive, so the gradient has to be positive. So simply we need to sketch a line with positive gradient. So we can assume it has certain value of velocity, vertical component of velocity at A, and then velocity keep on increasing. So this is how we can draw the line. So this should not be from the origin, because at point A, block has certain velocity of vertical component. So this is how you need to sketch. Question 3 says a block is pulled in a straight line along a rough horizontal surface by a varying force capital X, as shown in figure 3.1. A resistance is negligible. Assume the frictional force exerted on the block by the surface is constant and has magnitude 2.0 newtons. The variation with time t of the momentum of the block is shown in figure 3.2. So we have momentum against time graph. Part A says state Newton's second law of motion, and Newton's second law of motion, simply we can state F is equal to delta P over delta T, and F here is the net force. So simply we can say resultant force on any object is proportional to rate of change of momentum, or simply you can say is equal to rate of change of momentum. So this is how you need to define Newton's second law of motion for AS physics. So let me show you how you can write down your answer. So this is how you can write down your answer. So these things you have to mention. You need to say resultant force on an object is proportional to, or you can say is equal to, the rate of change of momentum. Means F net is equal to delta P over delta T. So this is the true form of Newton's second law of motion. Part B says use figure 3.2 to determine for the block at time t is equal to 2.0 seconds the magnitude of the resultant force on the block. Mean only at this time t is equal to 2.0 seconds. So we have here momentum on y-axis and we have t on x-axis. So if you look at the gradient of this one, gradient will be equal to delta P over delta T, and delta P over delta T, this is equal to net force, mean this is equal to the resultant force. So simply we need to calculate the gradient. So we can take any point on this line, any 2 points, and we can find the gradient, because gradient is constant. So resultant force is constant from 0 to 4 seconds. So we can take this point. So here we have value of momentum, that is equal to 6.0, minus we have 0 because at this point we have 0.0, and we can divide this one by 4.0 because time is 4 minus 0.0, simply 0 you can write. So we will get this is equal to 1.5 newtons. So this is value of resultant force. And for the second part, we need to determine the force X, means this force. This force is the applied force. So we need to understand Fx, we can say the force X minus friction. Minus friction, this is equal to F net, mean this is equal to the resultant force. But for this question, we need to calculate force X. So I'm writing just X here. So this will be equal to F net plus frictional force, I'll be writing small f. F net we have calculated, that is equal to 1.5, and frictional force is given in the question, that was equal to 2.0. So it means this is equal to 3.5 newtons. So the value of force X is equal to 3.5 newtons. And this question has only 1 mark. If you got the right answer, you will get 1 mark. Part C says, on figure 3.3, sketch a graph to show the variation of force X with time t from t is equal to 0 to t is equal to 6.0 seconds. We have already discussed until this point the value of the net force F net. This is equal to 1.5, and the value of Fx between 0 and 4, that is equal to 3.5 newtons, because 1.5 plus 2, and in this case means between 4 and 6 seconds F net is equal to 0. So the value of X has to be equal to friction, and value of friction is equal to 2.0 newtons. So simply we have to divide this one into 2 parts, 0 to 4 seconds and 4 to 6 seconds. So simply we can write down 0 to 4 seconds. In this interval of time, value of Fx, this is equal to 3.5 newtons, and from 4 to 6 seconds Fx is equal to 2.0 newtons. That's all. So now we need to sketch the graph. So simply we can sketch between 0 to 4 seconds. The value of X is 3.5, so this is 3.5 newtons. So we can draw the horizontal line, and between 4 and 6 seconds value of X is 2 newtons. So this is how you can sketch the graph. Let me show you the clear one. So this is how you can sketch. And that's all for this lesson. Means we have discussed almost half of this paper, and remaining half I'll be uploading by tomorrow. And if this video was helpful, please like and subscribe, and also leave some comments in comments section. And if you have any questions, also leave in the comments section, and I will try to answer as soon as possible. See you in next video.